May peace be on all of you. Myself, Dr. Majid Khan, Associate Professor, Loknete Dr. J.D. Pawar College of Pharmacy, Kalwan, Nasik. I welcome all of you in this antihistamine chapter. In this video, that is lecture 2, we will discuss about the SAR, uses and side effect of first generation antihistamine, that is H1 blocker. Learning outcome, the student learning goal, SAR of different classes of first generation antihistamine, uses and side effect of antihistamines. So let us start. Structure activity relationship of H1 blocker or antihistamine. So it is the general structure of antihistamine. If you see here, this general structure consists of various parts like aromatic ring part. So here there are two aromatic ring, aromatic 1 and aromatic 2. Then here there is a X, that is called as connecting item. Then there is a chain, alkyl chain. Then there is a nitrogen, and then there is a alkyl groups. So these are the general structure of antihistamine. So here this structure, in this structure, aromatic 1, that is ring, aromatic ring, first aromatic ring is aryl including phenyl or substituted phenyl, or it may be heterocyclic group such as pyridine or thiophene ring. Similarly, aromatic 2, that is second aromatic ring, is a second aryl or aryl methyl group. So two aromatic ring is there. One aromatic ring may be simple phenyl ring, may be substituted phenyl ring, may be heterocyclic ring such as thiophene and pyridine. And second aromatic ring, it is also aromatic aryl methyl group or simple phenyl ring. Now X, this X, that is connecting moiety, it may be oxygen, it may be carbon, and it may be nitrogen. Then CH2, it is called as spacer or ethylene bridge. So CH2N, so it is a CH2N, represent the carbon chain, usually ethyl. Then there is a NRR dash, represent basic terminal amine function. So it is a general structure of antihistamine. Now let us discuss one by one. So here the first is aryl group. So there are two aromatic ring as we see. So here the diaryl substitution pattern is present in both first and second generation antihistamine, and it is essential for H1 receptor affinity. Furthermore, several SAR studies suggest that 2-aryl moiety must be able to adopt non-coplanar conformation. So it is an important point. This aromatic ring, that is 2 aromatic ring, it should be non-coplanar relative to each other for optimal interaction with H1 receptor. So in order to bind with H1 receptor, it is important that this 2 aromatic ring should be non-coplanar. These two aromatic system may be linked as in tricyclic antihistamine like phenothiazine, dibenzocycloheptane or heptane, but again they must be non-coplanar for effective receptor interaction. So these two aromatic ring may be in the fused form or it may be separated. So in fused form, like in phenothiazine, dibenzocycloheptane, this two aromatic ring is in fused form, but again it should be non-coplanar to each other. Most H1 antihistamine contains substituent in one of the aryl ring, usually benzene, and this influences the histamine potency. So this aromatic ring may contain substituent. So these are the important characteristic of first part, that is aromatic rings. Then second, the nature of X. So the nature of X provides the basis of chemical classification of antihistamine. When X equal to nitrogen, then it is ethylenediamine. So as we seen in previous video, classification of antihistamine. So in that, if X equal to nitrogen, it is ethylenediamine, or in other words, ethylenediamine contain nitrogen as a connective moiety. When X equal to carbon attached to either oxygen in ethanolamine ether series. So this class ethanolamine ether series, here the X contain carbon which is attached to oxygen, that is ether group. Similarly, when X equal to carbon, then it is alkylamine class. And last one is X equal to CHN, which is seen in piperazine derivative. So depending upon this connecting carbon, that is X, there are various classes of antihistamine. When X equal to nitrogen, then it is in ethylenediamine class. In case of ethanolamine ether, here the X equal to carbon attached to oxygen. In case of alkylamine class, X equal to carbon, and in case of piperazine derivative, X equal to CHN. Then third one is alkyl chain. Most of the structure of classic antihistamine contain ethylene chain CH2CH2. Extension and branching of this chain result in less active compound except promethazine. This chain consists of 2 or 3 carbon which may be ring form, may be saturated or unsaturated. In most of the cases of antihistamine, this chain is a ethylene bridge, but it may be sometime branched, or it may be in cyclic form, it may be saturated or unsaturated. So it is about the alkyl chain. Then terminal nitrogen atom. In many first generation antihistamine, the terminal nitrogen is a simple dimethyl amino moiety, and it may be part of heterocyclic rings such as pyridine, pyrimidine and phenothiazine. It is presumed to be protonated when bound to receptor. The amine moiety is also important in development of stable solid dosage form through the salt formation. So this terminal nitrogen, generally it is basic in nature, and it may be simple dimethyl amine type, but it may be in cyclic form like pyridine and pyrimidine. So it is presumed that when the antihistamine bind to their receptor, then this nitrogen is get protonated, and it is this nitrogen also important for stable solid dosage form formation through the salt formation. Then last one is R group. So it is maybe simple attached to aliphatic amine, or usually simple alkyl group, usually methyl or sometime aryl group. So R may be generally it is a simple alkyl group like methyl ethyl, but sometime it may be aryl group. So it is the main component of general structure of antihistamine, or you may call it is a general SAR of antihistamine. Now one by one each class we will see the SAR. So in that first class, that is SAR of ethylenediamine. So it is a general structure of ethylenediamine. So why it is called as ethylenediamine? Because it contains ethylene bridge and there is a amine on both sides, diamine. Therefore it is called as ethylenediamine. It is characterized by presence of nitrogen connecting atom. So here X equal to nitrogen, and 2 carbon atom chain between 2 aryl ring and tertiary amine group, and there is a 2 carbon chain between the aromatic ring and this terminal amino group. So it is a characteristic of this type of compound. So in that first point, Phenbenzamine was the first clinically useful member of this class and served as a prototype for development of more effective derivative. So it is the first drug of this series, that is Phenbenzamine. So it contains nitrogen as a connecting, then CH2 as a ethylene bridge, then nitrogen is there, and then this CH3 is the alkyl group. Here aromatic ring is, one aromatic ring is phenyl and second one is benzyl group. This one is benzyl, phenyl with CH2, that is benzyl. So it is a Phenbenzamine, first class of this series. So if we, point number 2, replacement of phenyl ring of Phenbenzamine with pyridine ring give more potent antihistamine, for example Tripelennamine. So here there is a replacement of one phenyl ring of phenbenzamine with pyridine ring. This one is pyridine ring. Then it gives a new drug, that is tripelennamine. So here there is only one change in phenbenzamine structure. So in case of phenbenzamine, here is phenyl ring, but here triphenyllamine, this phenyl ring is replaced by pyridine ring. So it is a triphenyllamine. Next, substitution of methoxy group on fourth position of benzyl group of triphenyllamine leads to formation of more potent mepyramine. Again here there is a methoxy group where on fourth position of benzyl group. So it is a benzyl group of triphenyllamine. So on fourth position, when we introduce methoxy group, it gives a new drug, that is mepyramine. So here is a methoxy group on fourth position of benzyl ring. So it is a more potent drug, mepyramine. Both these drugs, that is triphenyllamine and mepyramine, having less drowsiness activity as compared to first drug, phenbenzamine. Next point, replacement of 4-methoxyphenyl group of mepyramine with thiophene give more potent compound methapyrilene. So change in mepyramine previous drug structure, that is mepyramine, if we replace 4-methoxyphenyl ring with thiophene, so it is a thiophene, then it gives the new drug called as methapyrilene, which is also potent drug. Next point, replacement of pyridine of mepyramine with pyrimidine give doxylamine, which is more potent than phenbenzamine. So when there is a replacement of pyridine ring of mepyramine, so mepyramine, previous drug mepyramine, so when we replace pyridine ring with pyrimidine, so it is a pyrimidine ring, it gives new drug doxylamine, which is more potent. So here instead of pyridine there is a pyrimidine, so this one is pyrimidine. So here the changes in mepyramine structure, so it gives doxylamine, which is more potent. The next point, in exceptional cases as in antazoline, the alkyl tertiary amine in phenbenzamine is replaced with imidazoline ring. So here there is an exceptional case where the amine group, terminal amine group, is replaced by imidazoline ring. So here there is a imidazoline ring, and example is antazoline. So it is an exceptional case where this alkyl nitrogen is in cyclic form. So it is about the SAR of ethylenediamine. Now second class, antihistamine second class, that is SAR of amino alkyl ether. So here is general structure of amino alkyl ether. So as name indicate, amino means it is a amino group, alkyl ether, so here oxygen, X equal to oxygen, so here it is called as amino alkyl ether because ether linkage is there, therefore it is called as amino alkyl ether. The example of this class is diphenhydramine, bromodiphenhydramine, carbinoxamine, doxylamine, Clemestatine. So here the general the close structural analog of diphenhydramine, so it is a first drug of this category, that is diphenhydramine. So it contains aromatic ring, then carbon attached to oxygen, CH2 CH2, nitrogen, methyl twice. So it is a first drug, that is diphenhydramine. So here first point, close structural analog of diphenhydramine is bromochlorodiphenhydramine, share both antihistamine and anticholinergic effect as well as side effect. So it is a derivative of diphenhydramine only on para position bromo group, and here is a chloro group. So it is a bromodiphenhydramine and chlorodiphenhydramine. Isosteric replacement of one phenyl ring of diphenhydramine by pyridine and other minor changes give doxylamine and carbinoxamine, which is similar to diphenhydramine as a H1 antagonist. So here replacement of one phenyl ring of diphenhydramine by pyridine ring, and other minor changes give two drug doxylamine and carbinoxamine, which having the similar effect as an H1 antagonist. Next point, in case of clemestatine, additional carbon atom between oxygen and basic nitrogen is incorporated into the ring. So here in clemestatine there is an extra carbon. So here is a extra carbon between oxygen and basic nitrogen. So it is oxygen and this one is nitrogen. So here there is a 3 carbon instead of 2 carbon. Here is a 3 carbon. So in case of clemestatine, additional carbon between oxygen and basic nitrogen which is incorporated into ring, and this carbon is a part of this ring. So there are 3 carbon between oxygen and terminal nitrogen, and this carbon is in cyclic form. Similarly, in case of cetastatin, same is there, that is nitrogen is in cyclic form. So it is the SAR of this compound. Now here the important point of this class is antihistamine versus anticholinergic activity. The diaryl tertiary amino alkyl ether structure that is characterizes this compound also serve as a pharmacophore for muscarinic receptor. As a result, the drug in this group possess significant anticholinergic activity, which contribute not only to their therapeutic uses as an antiemetic, motion sickness and anti-Parkinson drug, but also their adverse effect profile like dryness of mouth, constipation, urinary retention, blurred vision, etc. All above drug possess increased selectivity for H1 receptor over muscarinic receptor. So in this category, that is amino alkyl ether. So as this one is ether containing drug. So as we know, acetylcholine, which is also ether. So here there is a anti-muscarinic effect is also observed because these drugs having ester group. So and as we seen in receptor, H1 and H2 receptor having the structural similarity with muscarinic receptor. So this type of drug also bind to muscarinic receptor and give anti-muscarinic activity. So this anti-muscarinic activity may be associated with therapeutic effect like antiemetic effect, motion sickness and anti-Parkinson effects. So these effect is due to the blocking of muscarinic receptor. Similarly, these drugs also produce side effect due to muscarinic receptor binding, which may include dryness of mouth, constipation, urinary retention, etc. So these drugs produce anti-muscarinic activity also. But here introduction of alkyl substituent at carbon 2' and 4' of one aromatic ring result in significant change in selectivity. So aromatic ring, especially 2' position and 4' position. Suppose this one is aromatic ring. So 2' position means this one is 2' position and this one is 4' position. So it is a 2' and this one is 4' position. So when we substitute this 2' and 4' position, the selectivity of these drugs towards the muscarinic and histaminic receptor is changes. So it is observed that in tissue-based assay for antihistamine versus anticholinergic activity with increasing alkyl group size, methyl, ethyl, isopropyl, butyl at carbon 2, large decreasing antihistaminic activity and increasing anticholinergic activity. So when we substitute on second dash position, alkyl substitution on second dash position, then the antihistaminic activity decreases and increase in anticholinergic activity. While if we put substituent on 4 dash position, then the anticholinergic activity decreases, antihistaminic activity increases. So in short, if we put substituent on second dash position by alkyl group, antihistaminic activity decreases, anticholinergic activity increases. When we put substituent on 4 dash position, then anticholinergic activity decreases, antihistaminic activity increases. So it is the antihistaminic versus anticholinergic activity. Now next class, that is SAR of alkyl amine, also called as propylamine derivative. So here there is a 3 carbon between nitrogen and this aromatic ring, and the connecting X equal to carbon. So therefore propyl means 3 carbon, that is propylamine. So it is a general structure of this type of category, that is propylamine derivative or alkyl amine. So the propylamine antihistamine are characterized structurally by an sp3 or sp2 carbon connecting atom. So this carbon, that is connecting carbon, it may be sp2 hybridized or it may be sp3 hybridized. Those propylamine with saturated carbon connecting moiety are commonly called as phenyramine. So this connecting carbon may be sp2 hybridized or sp3 hybridized. When it is sp3 hybridized, means it is saturated, then it is called as phenyramine. All of phenyramine consist of phenyl and 2-pyridyl aryl group and terminal dimethyl moiety. This compound different only phenyl substituent at the phenyramine, that is when hydrogen on aromatic ring, then it is called as phenyramine. Then chlorophenyramine. So here connecting carbon, when connecting carbon is saturated, it is called as phenyramine. So there are 3 compound: phenyramine, chlorphenyramine and bromophenyramine. So here the difference only the para position substituent. When the para substituent is H, then it is phenyramine. When para substituent is chloro, then it is chlorphenyramine. It is bromo, that is bromophenyramine. Then propylamine with unsaturated connecting moiety, that is sp2 hybridized carbon as a X. So it includes simple open chain alkyl derivative, that is pyrobutamine and tripolidine. So here the connecting carbon is double bonded, unsaturated. So here also there is a unsaturated or sp2 hybridized carbon, which is a connecting carbon. Example pyrobutamine and tripolidine. Here in case of tripolidine, E isomer is more potent than Z. So here they due to double bond, there is a E and Z isomer. So in case of tripolidine, E isomer is more potent than the Z isomer. Then next category, SAR of Piperazine, or called as cyclisine derivative. It is also considered cyclic ethylenediamine. However, connecting moiety X equal to CHN, and this connecting carbon CHN and carbon chain and termino amino function and nitrogen of connecting group all are the part of piperazine moiety. So here connecting X, which is CHN, then spacer chain, that is methylene chain, terminal amino function and nitrogen are the part of cyclic compound. So here this is a CHN X, then it is a ethylene chain and terminal nitrogen, all are in cyclic form. Therefore it is called as piperazine derivative. Example, so it is a general structure and it is the example, that is cyclisine. It is a first drug of this category, cyclisine. So here the important characteristic, that is connecting carbon X, which is CHN, then carbon chain termin terminal amino function and nitrogen of connecting group are in cyclic form. So it is the first example, cyclizine. Parachloro derivative of cyclizine, that is chlorcyclizine, was the more potent than the cyclizine. So on cyclizine structure there is a on para position chloro group, that is chlorcyclizine, which is more potent than the cyclizine. Then N-methyl group of chlorcyclizine, when replaced by a substituted benzyl group, it gives meclizine and buclizine, show less antihistaminic property. So here N-methyl group of chlorcyclizine replaced by substituted benzyl group, then it gives meclizine. So it is a substituted benzyl group, meclizine and buclizine. So here the N-methyl group of chlorcyclizine is replaced by the substituted benzyl group in case of meclizine and buclizine. Next point, N-substituted, that is 2-hydroxy-ethoxy-ethyl derivative of chlorcyclizine, is a potent H2 antagonist with central side effect. Example, hydroxyzine. So here in case of chlorcyclizine there is a methyl group, but when we replace this methyl group with 2-hydroxy-ethoxy, so it is a 2-hydroxy and this one is ethoxy, it gives new drug hydroxyzine, which is a H2 antagonist, Then next point, carboxylic derivative of hydroxyzine or active metabolite of hydroxyzine called as cetirizine, which is a potent antihistamine. So here this alcoholic group is replaced by carboxylic group. So it is a carboxylic acid derivative of hydroxyzine, that is the famous one is cetirizine, which is a more potent antihistamine. So cetirizine is a metabolite of hydroxyzine, or it is a cetirizine is a carboxylic acid derivative of hydroxyzine, which is a more potent antihistamine. The next class, that is SAR of tricyclic compound, that is called as phenothiazine. The search for effective anti-malarial leads to investigation of phenothiazine derivative, in which bridging entity is sulfur. Subsequent testing found that phenothiazine class of drug had only antihistaminic activity, not only antihistaminic activity but also pharmacological profile of its own, considerably different from that the ethylenediamine. This began the era of development of useful psychotherapeutic agent, phenothiazine antipsychotic. The phenothiazine derivative that display therapeutically useful antihistaminic action contain 2 or 3 carbon branched alkyl chain between ring system and terminal nitrogen atom. This differ significantly from the phenothiazine antipsychotic series, in which an unbranched propyl chain is required. The branched alkyl chain contain a chiral carbon, giving rise to optical isomerism. So this type of compound, that is phenothiazine, when it is discovered, so it having only antihistaminic activity. Then later it is studied that these drugs also have antipsychotic activity also. But the structural difference between the structure of drug which are used as antipsychotic and antihistaminic activity is that generally the drug which having antihistaminic activity is a branched alkyl side chain. So these drug contain branched alkyl side chain, antihistaminic drug, while the drug which having antipsychotic activity, it does not having the branching on propyl side chain. So it is an unbranched propyl side chain compound. So in short, the drug which having branched side chain show antihistaminic activity, and the drug which is unbranched propyl side chain show antipsychotic activity. So it is the structure of phenothiazine. So this derivative contain 2 to 3 carbon between alkyl side chain between the ring and nitrogen. So it is a terminal nitrogen, it is the ring. So it may contain 2 to 3 carbon between these two nitrogen. So it is a characteristic of this type of class. There is a 2 to 3 carbon between terminal nitrogen and between the nitrogen of cyclic group. So it is the general structure of phenothiazine. In general, combination of lengthening of side chain and substitution of lipophilic group on second position of aromatic ring result in compound with decreased antihistaminic property but increase antipsychotic property. So lengthening of side chain and substitution of lipophilic group on second position of aromatic ring, generally compound show antipsychotic activity more but less antihistaminic activity. Next point, promethazine. Promethazine is a parent member of this series, is moderately potent antihistamine, and it also has antiemetic and anticholinergic activity. So example is promethazine. So this one is a promethazine. So it is a structure of promethazine. So promethazine is a parent member of this class, moderately potent antihistamine, and also has antiemetic and anticholinergic activity. Next point, number of carbon atom of side chain increases from 2 to 3 carbon. Trimepyrazine obtained, which is 2 to 5 times more potent than promethazine. So if we increase the number of carbon atom of side chain from 2 to 3, then we get trimepyrazine, which is more potent than the promethazine. Next point, when the terminal nitrogen is in cyclic form, it gives methadiazine, which is potent antihistamine. So here terminal nitrogen, it is in cyclic form. So here there is a simple aliphatic form, but when the terminal nitrogen is in cyclic form, the compound name is methadiazine, which is more potent antihistamine. Now next point, in dibenzocycloheptene and dibenzocycloheptane antihistamine, the sulfur of phenothiazine has been replaced by vinyl group in brackets cyproheptadine or saturated ethyl bridge azatidine, and the nitrogen is replaced by sp2 carbon and terminal nitrogen is in cyclic form. So if we see the structure of phenothiazine, so phenothiazine structure consists 3 ring. First one is aromatic ring, then second one is that is sulfur containing ring. So as this here, it is a phenothiazine ring. This 3 ring is called as phenothiazine ring. So it is aromatic ring, then sulfur, then either nitrogen, and then phenyl ring. So if we changes two changes, that is sulfur is replaced by vinyl group. Sulfur is replaced by vinyl group or saturated ethyl bridge. Either sulfur is replaced by vinyl group or by ethyl bridge, saturated ethyl bridge, and the ring nitrogen is replaced by sp2 carbon and terminal nitrogen is in cyclic form. Then this compound is called as dibenzocycloheptene and dibenzocycloheptane. So here heptane means alkene, here is alkane, heptane. So if we compare the phenothiazine structure, there are 3 changes in phenothiazine structure. First change, when we replace sulfur of phenothiazine ring with either vinyl group, example cyproheptadine, so it is a vinyl group, sulfur is replaced by vinyl group, or saturated ethyl bridge, this one. So it is a saturated ethyl bridge, that is azatidine, and nitrogen is replaced by sp2. So here in case of phenothiazine, nitrogen is there, but here it is replaced by sp2 carbon. And last one is terminal nitrogen is in cyclic form. So here it is in cyclic form. So this type of compound is called as dibenzocycloheptene. So it is the example of dibenzocycloheptene because it contains double bond heptene, ENE, and azatidine is an example of dibenzocycloheptane. Dibenzo matlab 2 benzo, cycloheptane. So it is a heptane, 7 member ring, here also 7 member ring. So in short, there is 3 changes in phenothiazine ring. First change, instead of sulfur there is a vinyl group or it may be saturated ethyl bridge. Second change, nitrogen of central ring of phenothiazine is replaced by carbon, that is sp2 carbon. And third change is, that is terminal nitrogen is in cyclic form. So here is the example, that is cyproheptadine. It is an example of dibenzocycloheptene, and azatidine is an example of dibenzocycloheptane alkene. Next point, azatidine, instead of benzene ring, pyridine ring is there and 10-11 double bond is reduced. So in case of azatidine, instead of phenyl ring there is a 1 pyridine ring. Here there is a 2 phenyl ring. In case of cyproheptadine there is a 2 phenyl ring. But in case of azatidine, 1 phenyl ring is replaced by pyridine ring and there is a saturated bond. 10-11 there is a no double bond here. So it is a saturated bond. Loratadine, this one is loratadine. It is a alkyl ester of azatidine. So it is a ester group. So loratadine, it is a ester group. So it contains ester COO ethyl. So it is a COO ethyl, that is ester. It also contains chloro group. It also contains, here is a chloro group on benzene ring. So it is about the SAR of all classes of H1 blocker or antihistamine. Now the uses and side effect of H1 blocker. So uses, H1 antihistamine are clinically used in treatment of histamine mediated allergic condition. These indication may include allergic rhinitis, allergic conjunctivitis, contact dermatitis, rhinorrhea, that is running nose, urticaria, angioderma, pruritus, that is insect bite, anaphylactic reaction, nausea, vomiting, sedation. So these are the main uses of antihistamine. H1 antihistamine can be administered topically through the skin, nose, eyes, or systematically based on the nature of allergic condition. Side effect, the most adverse common side effect is sedation. Other include, that is dizziness, tinnitus. Tinnitus means perception of noise and ringing in the ear. Blurred vision, euphoria, incorporation, anxiety, increased appetite leading to weight gain, insomnia, and tremor. Infrequent adverse effects include urinary retention, palpitation, hypotension, and headache. So it is the main side effect of H1 or antihistamine. In next video, that in video lecture 3, we will cover second generation antihistamine, mast cell stabilizer, topical H1 blocker, and PPI, that is proton pump inhibitor. So if you like the video, then subscribe the channel. Thank you very much.